For question 1, we know x and y have joint density function, and we need to find a so that the above defined is a valid joint density function. This is question 1. If the function defined is a valid joint density function, the double integral of it should be equal to 1. Like the integral from -1 to 1, -1 to 1 of 1 plus xy over a with respect to x and y. This should be 1, and we can easily see this is an odd function. So we can easily see that a should be equal to 4. Question 2, we need to show that if whether x and y are uncorrelated. First, we calculate the expectation of x, y. This should be equals to the integral from -1 to 1, -1 to 1, xy, 1 plus xy over 4 with respect to x and with respect to y. This should be equal to and for this part, this is an odd function, so the result is 0. And for this part, the result is 4 over 9. So the final result should be 1/9. And we calculate the expectation of x. This should be equals to the integral from -1 to 1, -1 to 1, x, 1 plus xy over 4 with respect to x and y. This equals to 1 over 4 times x dx dy plus x square y dx dy. Then this should be 0. This should be 0, and as you can see, this is an odd function too, so this is also 0. And actually, we do not need to calculate the expectation of y, because we know that the expectation of x and the expectation of y, their product should be 0, and this is not equal to the expectation of xy. Here we can see that the expectation of x times the expectation of y equals 0, which is not equals to the expectation of xy here. Because they are not equal, so we know that the x, y are not uncorrelated. And because they are not uncorrelated, we know that x, y are not independent. For question 4, we need to find the joint density function of x squared and y squared. So that's z equals x squared and w equals y squared. And we calculate the Jacobian determinant, this should be 2x 0 0 to y, and this should be 4xy. Z equals x squared, w equals y squared, and this has 4 roots. So for z between 0 and 1, w between 0 and 1, the Jacobian determinant should be equals to 4 z times w square, where I equals 1, 2, 3, 4. And we know that the function of CW should be CW square over Jacobian 1 and minus Z square W square over Jacobian 2 and so on. And this equals to 4 CW square times 1/4 times 1 plus CW square plus 1 minus CW square plus 1 minus CW square plus 1 plus ZW square, and this is 4 ZW square, 1 over 4 ZW square. When Z is less than 0 or Z is greater than 1 and W is less than 0 or W is greater than 1, the density function of ZW should be 0. So this is the final result of the density function of ZW. Zero, 1, otherwise. So with Fz equals to 1 over 2 Z square, and Fw 1 over 2 W square. So this is a joint density function of x squared and y squared. And as you can see here, the density function of ZW equals 1 4 times ZW square, which is equals to this. This is equals to the density function of z times the density function of w. So x squared and y squared are independent.